Hey guys, welcome back to 2 Minute Coders. Today we're doing LeetCode problem 853, which is car fleet. So just pause the video here and read the question. Okay, so first thing you have to do is always look at the constraints. So as you can see here that position.length can be n and n can be 1, right? So in the case that it's 1, we just have to return 1, right? So if there is only one car, return 1. So if position.length equals 1, can return 1. Okay, but for our solution, what we're going to do is we're going to initialize a stack to keep track of all the car fleets. Okay, so this is going to be of type double. Now the reason that this is going to be of type double is because we're going to do an operation which is finding the time that it takes for a car to reach the target. Okay, so first what we want to do is we want to initialize a 2D int array. Let's just call it combine equals new int array, which is going to be the length of position.length, and it's going to be 2 deep, right? So what we're going to do here is we're just going to combine these two arrays of position and speed. So instead of iterating through two arrays, we can just have one combined array. All right, so the first kind of the first position of the array is going to represent position, and the second is going to represent speed. Okay, so each iteration of this array is going to look something like this. Okay, just say for example. Okay, so this is going to represent the first car's position and its speed, and second car's position and its speed. All right, so that's just what we're doing here. Now to add all of the values from two of these arrays into this combined array, we're going to use a for loop. So for int I is equal to 0, I less than position.length, and I plus plus. So combine. So basically what this is going to say is for the ith position in each row in the first column. Okay, this represents the row and this represents the column. So because we want the first of each iteration, we're going to have to go row wise. Right, so that's going to equal position at I, and then similarly each iteration at column 1, which is because we start from 0 index, this is going to be the second column. Right, so if you just visualize it, I'm just putting some faux values in here. So in this one where we're setting the position, we're just going to the first column of each row. Okay, and then for this one, we are going to the second column of each row, right? So this is going to be speed at I. Right, now that we have our combined array, what we're going to do now is we will sort the combined array in ascending order on the basis of position, so we can see the actual position of all the cars on the road. Okay, so the reason why we're going to do this is because our main logic is going to be to iterate from the closest to the target, which is position 10, okay, and see if the second closest to the target, which is position 8, catches up to 10. Okay, if it catches up to 10, then we can combine it as one fleet. Okay, so for every position that we iterate over, we need to see that will the car behind it catch up to it. Okay, so let's sort the array. So sort combine length minus 1. Sorry, just combine and then we have to use the Java comparator utility. Comparator dot comparing. What are we comparing? We're comparing ints because this is an int array. Okay, and then we use a lambda function. So this specifies that we are sorting on the basis of position. This would mean that we're sorting on the basis of speed. Okay, so we have to tell it from which column are we sorting it. Okay, now to iterate over our combined array. Combined length minus 1. It goes all the way down to 0, and it decrements. So you can see here that we are starting from the back of the array, and so we're going right to left instead of left to right. That's just because this is being sorted in ascending order. Okay, if we were to sort this in descending order, where our 10 would be at the start of the array, then we would just have a normal incrementing for loop. But because we sorted it in descending order, and the position that is closest to the target is on the right of the array, we will start from the right of the array. Right, so how are we going to find out if there's an intersection? So we'll take a double to current time. We have to bind it to a double data type. So our double is going to equal target minus the position of the car. Okay. So the amount, so target minus the position. So this would tell us the distance that it has to travel, and then we divide it by speed, right? So that's how you get time, distance divided by speed, right? Now once we have that, what we're going to do is we have to find if the current time will catch up with the previous current time, which in this case, where the previous current time is of the car ahead. Right, so first we have to make sure our stack is not empty, so we can use that. And what we also have to make sure is that our current time that we are at right now is less than or equal to our stack.peak. Okay, so stack.peak is going to give us the value that is at the top of the stack without popping it. Okay. So what you can see here is if the stack isn't empty, which means that there is a car ahead of us, and our current time, which is the time that it would take for us to reach target, is less than the current time of the car ahead of us, meaning that at some point we will pass it, but because of this constraint that a car can never pass another car ahead of it and it will become a fleet, then we don't have to add it to our stack because we know that that will eventually become a fleet, right? So what we're actually returning here is the size of our stack. Okay, so if there aren't going to be any intersections, or the current time that we're currently at is not going to intersect the one on our stack, then we are going to push it onto our stack because that's going to become a separate fleet. Okay, and we only have to compare it to the top of our stack because we know that, for example, if our stack had values like this, right? Or actually, let's say this. Say this is the top of our stack. Okay. So actually, yeah, this would be the top of our stack. Okay. Say for example, 8 is the top of our stack, and our current time is 9. So 9 is not greater. Oh, I mean, sorry, 9 is not less than 8. So it would then be added. Okay. We don't need to compare 9 to 5 because we know that, for example, if it's 7, right, 7 is only going to catch up to 8 and then it's going to assume the same speed as 8. Okay, it's never going to catch up to 5 because it's going to assume the same speed of 8. So if 8 never catches up to 5, then we know that 7 also is never going to catch up to 5. Right, so let's submit. Right, perfect. So that was LeetCode problem 853. Hope you guys enjoyed and understood it. Subscribe for more.